All right, this is Chapter 3, Lesson 2, Rational Numbers. So, rational numbers, we can actually take a look at this graph right here. So, rational numbers are these numbers right here. So, rational numbers actually are in a set called the real numbers, and real numbers include irrational numbers and rational numbers. Irrational numbers, probably the most famous is pi, 3.14. It's a number that never repeats, okay? Rational numbers are any numbers that can be written as a fraction, either positive or negative, but they have to be able to be written as a fraction, okay? Rational numbers include integers. Integers are your positive and negative numbers, so negative whole numbers, so like -3 is an integer, but 3/4 is a rational number. -3/4 is a rational number. Okay, irrational could be pi. Whole numbers include 0, so 0, 1, 2, 3, they have to be positive. And then natural numbers are the numbers 1, 2, 3, so on and so forth. But they're also positive integers. So whole numbers include 0. Integers include all of your negative numbers, all of your negative whole numbers, I should say. And rational numbers are anything that can be written as a fraction. So when you first learned to count using the numbers 1, 2, 3, so on and so forth, you were using members of the set of natural numbers. If you add 0 to the set of natural numbers, the result is the set of whole numbers, W. Whole numbers and their opposites make up the set of integers, which is usually indicated by the letter Z. And any number that can be written in the form A over B, where A and B are integers and B does not equal 0, is part of the set of rational numbers, which is often denoted by the variable Q. Okay, so any number that can be written in the form A over B, where A and B are integers and B is not 0, is a part of the set of rational numbers. All right, so let's take a look at a couple of examples. I'm going to write 0.64 as a fraction in simplest form. So 0.64 I can write as 64 over 100, and then I can simplify by dividing both of these by 4. So 64 divided by 4 is 16, and 100 divided by 4 is 25. Okay? So this is really 64 hundredths. That's how you would actually say it instead of 0.64. A handheld video game system weighs 9 and 675 thousandths ounces. Write this decimal as a mixed number in simplest form. So the 9 is a whole number, so it stays out front. The 675 goes on top of my fraction bar, and I write 1,000 underneath it because there's 3 numbers, so 3 zeros. Then I can simplify. GCF of 675 and 1,000 is 25, so I divide both of these by 25. 675 divided by 25 is 27, and 1,000 divided by 25 is 40. Here's a little chart to kind of remember billions, millions, thousands, ones, and then your decimals. Okay. You can also write repeating decimals as fractions, the fraction with a fraction bar, the bar notation. So if I have 0.6 repeating, I can multiply this by 10. So 10 on both sides, which gives me 10 times n equals 10 times 0.6 repeating. When I do that, I get 10n equals 6.6 repeating. Then I can subtract n from both sides. So subtract n from 10n to eliminate the repeating part of 0.6, because we said that n equals 0.6 repeating. So when I do that, I get 9n equals 6, and I divide both sides by 9, so n equals 6/9 or 2/3. You can always double check, do 6 divided by 9 in your calculator, you will get 0.6 repeated. Okay. All rational numbers can be written as terminating or repeating decimals. Decimals that neither terminate nor repeat, such as pi, are called blank. In that blank, you're going to write irrational numbers. Irrational numbers are numbers that never terminate or repeat. So pi is an example. It never terminates. It never actually repeats. There's no repeating pattern in it. Next thing I want to do is identify all sets to which each number belongs. So I have negative 2 and 6 11ths. So 2 and 6 11ths can be written as a fraction, so therefore it is a rational number. However, it's not a whole number, it's not an integer, it's not anything like that, okay? B is 1.313313331. This is a non-terminating and non-repeating decimal. It doesn't actually repeat. There is a pattern to it, but it doesn't actually repeat the pattern. So it's an irrational number. Okay, and then I have 45. 45 is a natural number, it's a whole number, an integer, and a rational number. It's all of those things, okay? So you start from the smallest thing and you work your way out. All right, there are a couple of try problems out below. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. All right, now that you've had a chance to try out the try problems, let's go over the answers together. So, letter A says write 0.45 as a fraction in simplest form. So I write it as 45 over 100, okay, and then I figure out what I can divide both of these sides by. 45 and 100 can both be divided by 5. 45 divided by 5 is 9, and 100 divided by 5 is 20. Okay. For letter B, write 5.882 as a fraction in simplest form. So I write it as 5/882 over 1,000. I can divide both 882 and 1,000 by 2. So divide by 2, divide by 2, I get 5, and 441 divided by 500. That is its simplest form. I cannot divide anything else by both of those numbers. For letter C, rap music accounted for 0.2 or 20 hundredths of the total music sales in a recent year. Write this decimal as a fraction in simplest form. So I write 20 over 100. I can divide both of these. The zeros cancel out, so I have 2/10. Okay, and I can divide both of these by 2. So I get 1/5. For letter D says write 0.32 as a fraction in simplest form. Okay, so basically all I'm going to do is actually say 32, and because that's what's repeating, I'm going to put that over 99. 32 over 99. And I can't simplify it, can't be simplified any further than that. 4.3 repeating as a fraction in simplest form. So this is going to be 4 3/9, which is really 4 1/3, because I can simplify 3/9 to 1/3 by dividing both numerator and denominator by 3. You can always double check any of these, okay? Next I have write negative 2 1/6, with the 6 repeating as a fraction in simplest form. Okay, so this one's a little bit more complicated. Okay. The 6 is what's repeating. However, I know that 1/6, so 1 divided by 6 gives me 0.16 repeating. So this is going to be negative 2 1/6. Okay. For letter G, it says identify all sets to which the numbers below belong. For letter G, I have 1 3/4. Well, 1 3/4 is a fraction, so this must be a rational number. I can't simplify it any further. It's not going to be a whole number or an integer or anything like that. I have 1.41424344. This is a repeating pattern, but it is a pattern, but it's not a repeating pattern. So this is an irrational number. Okay. Then I have negative 2. Negative 2 is not a whole number. It's not a natural number because it's not positive. Not a whole number because it's not positive. It is an integer because it's negative. It's a negative whole number, and it is rational. So integer and rational. right, and that is the end of chapter 3, lesson 2.